Okay, this is part 2 of the Flatirons overview. If you recall, last time I had used LMO trend and picked the closest thing to 0, and I did a delay time solution. I have some model profiles that I had determined using a weathering velocity of 2000 and the delay times I computed. So what I'm going to do now is I'm going to kill my picks, repick it with another technique, run tomography, and then stack, and then come up with, do some semblance velocity analysis, and then stack, do some CMP stacking within the program here. So the first thing is I'm going to go to my pick window here so we can see my picks. And these yellow picks, if you recall, were these pick event nearest time. So I'm going to turn those off. So here my red picks are the picks that were derived from the yellow picks that I moved into my user picks. And now I'm going to kill these picks. So I'm going to kill all my picks under pick manipulation, kill all first break picks, kill, yes. So if I reload here and if I go around the survey, you'll see I don't have any picks. So I'm going to take this other technique. Under this funnel here, I'm going to add a technique called first break picking threshold. And threshold, what it does is it finds the biggest event on my trace. So if I move this to 1.0, it's just literally finding on each one of these traces, it's moving down and it's finding the biggest event. And then as I slide this thing back here, the slider, it's actually looking up ahead above for something 0.4, 0.5, 0.3 times as big as it. And as you can see on these particular data, when I get to about 0.225, it does a pretty good job for this particular shot. So let's look around and see how it does at other shots. Not bad. I'm not going to worry about a few missed picks here and there. You can see over here on the right I have a missed pick or two. Some places, but no big deal. So what I'm going to do now is I'm going to run this as a batch mode. So here, start batch picker, and I'll just take a second or two to pick this. And now I'm going to have another kind of pick called pick FBP, which is first break picks underscore tap. So I'm going to open the pick dialog and copy the tap to user and copy it all. And since I don't have anything in my user picks anyway, since I just killed them, I'm going to copy over. So now if I close here, I'm not going to do an analysis at this point. If I reload my, I'm going to reload the record here. And you can see I have some of these missed picks that I just caused. And I'm going to turn off my threshold picker. So at this point, I have a new set of picks, and if I go around the survey, and I'm looking at the traces from 0 all the way out to 6,000, which happens to be my total offset range. So I have picked traces at all offset ranges here. So I'm ready to go into tomography. So go to my tomography window, our 3D Eikonal tomography. This is a plot of my surface elevations. I have some elevations for some shots that I never did fix that are wrong, but they're, as you can see, they're localized and they're really not really worth worrying about at this point because of the demo. And I'm going to create a new model, and I'm going to call this Demo 2. So I was playing with this earlier, and I came up with one called Demo 1. And I'm going to do a node spacing of 300 and 100. These are in feet, so these are roughly 100 by 30 meters. And I'll do 500 feet deep. I'll do a velocity of about 5,000 at the surface. I'll do 7,500 at depth. And I'll create a new model. Oops, Demo 2 I meant. Create a new model. Now if I click and drag over here, look at my profile, this is my initial model. As you can see, it goes down about 700 or 800 feet deep, or whatever it was I used, and I have no hit count since I have not done any ray tracing here at this point. So now I'm going to do I'm going to use all my offsets from 200 to 6,000. I'm going to just do 6 iterations to make this thing run faster, and I'm going to do 5 threads and let this thing run. And it shouldn't take too long. It should take probably less than a minute actually. Now I'm not trying to run the ultimate tomo here. I'm just trying to get you something to show you how it works, and it shouldn't be too bad. I'm going to compute some statics. So statics tab up here. Let me look at my model real quickly. My model goes from, here's my surface topography, and you can see my velocities are ranging from about 3,500 over here, but for the most part ranging from about 4,500 at the surface down to about 6,500 at depth, which is pretty close to what I was saying on my pick records. And you can see my ray tracing has been confined pretty much to the depths that I told it to move to. So I'm going to compute statics, and I'm going to put a datum at, let's say, minus 400, because most of my slower velocities are up here. And I'm going to do a datum at 100, and I'm going to do a replacement velocity of, let's say, 6,000. And I'll call this tomo 3D. I'm going to force my statics to be zero mean, so I don't have a big shift in my data. Compute statics. As you can see, I don't have much surface topography here, so I'm going to compute. So when I do my comparison of my statics, I'm going to look at no statics versus tomo statics. So QC here, under stacking velocities, I'm going to turn on my sparse picks, and I only have data down to 1,200 or so, 1,150, so I'll do 1,200 here. And my velocities are ranging from 3 to 19,000 here, which is a little excessive. So let me do the 9,000. And again, I don't have any statics computed, so let me apply my tomo statics. So we apply Shift T0, apply refraction statics, and here's my tomo 3D. I'm going to apply the sequence, and you can watch things change over here. You can see it focused really nicely. So I'm just going to stack, but it didn't move much because I have zero mean. And I'm just going to do one more over here just for the sake of expediency. And now I'm going to do a stack. So I'm going to view stacks along profile. I don't have any profiles, so I need to create one. So I'm going to create a new profile here, this middle button here. I'm just going to do a stack right down here. So I'm going to do, say, 100 spacing by 100 radius. So it's sort of going to do a little bit of super binning. Create a profile here. So cancel. So this is my current profile. So now what I'm going to do is I'm going to stack. And again, we have full lessons on this, so it's not important that you see how I'm doing this. I'll just call this, because this is from the surface. I'm not going to apply any statics, and I'll just create a new stack. So there's my stack here. And then before I change this to wiggle trace and all this, I'm going to do a tomo stack. And I'm going to apply my tomo 3D. And now when I go back over to here, I'm going to compare raw to tomo. And I will look at display wiggle traces, AGC, and I can change the window size here. I can zoom in, whatever. So as you can see here, I mean, these are not the biggest problem data set in the world, but I have a tomo solution compared to no statics, and just to give you some flavor of how easy it is to move around in this program. Okay, so thank you very much, and that'll be the end of part 2.